In this video, we're going to look at the discriminant of a quadratic and the nature of the solutions. The discriminant determines the nature of the roots, which determines the type of solutions we're going to get, and we are using the part of our quadratic formula that we find under the radical sign, because that's what's going to determine, are we going to get a nice number under there, a nice square number, and then that's when we got our two solutions where we add and then subtract and get 2, and we just type those in. And then we started seeing where we had numbers that were not squares, and we would have to get those solutions where the radical stayed in the answer. And they looked a little bit crazy, but that was fine. And that can all be determined simply by looking at the underneath the radical part of the formula b squared minus 4ac. So let's say we plug this in, our discriminant in, and we get an answer that is greater than 0. Okay? What that means is we can get 2 solutions. If it's a perfect square, right, versus a non-perfect square. So we'll have two rational solutions, or 2 real solutions. Okay. And we'll see some examples of that in just a moment. All right, so let's say we find our discriminant and it is less than 0. What can we expect then? So less than 0 meaning we're getting a negative number, so we will see a negative under our radical sign, which we now know we will turn into our I, a not real number, imaginary. So when we get a number less than that's a negative, we can get 2 complex solutions. Well, I just put the number there and I will spell it out here. So you do you on the notes here. So you can get 2 solutions that are not real, 2 complex solutions. Remember, complex numbers have our I. That are imaginary, not real numbers. Trying to organize my notes here. Okay, and what if we get one that equals 0? What can we expect to happen there? So 0, when we take the square root of 0, we get 0. And that means we're going to get 1 repeated solution, and this is in our book on Sabbath, we only write it once, okay? So we get 1 repeated, so we get 1 solution, okay? It's a repeated real solution. So this is where we would get a positive 6 and a positive 6, but you would only write it once. And I want to go back and elaborate here. When we get a positive number that's greater than 0, we can have 2 solutions, one that are rational or real, or we could get 2 solutions, right? If this is going to be if they are perfect squares. This is if we get a perfect square number, like 36, then we would get plus or minus 6, and this is a non-perfect square. Okay, the non-perfect square, then we would get 2 irrational solutions, again where the radical would be part of our answer, or we could get 2 real solutions in the end. So it could be irrational, 2 irrational, or 2 real again. I just want to add that this is giving us positive answers, so we could get positive perfect squares or non-perfect squares, and that's perfectly fine. And again, if it's less than 0, we're going to see some negatives in there, and that's where we would use our I to get our complex number. Okay, let's do an example here. This is our second example under quadratic formulas under this unit, and let's find the discriminant and then look at the nature of the solution so we can make that prediction. So we're going to look at 16q squared minus 32q plus 16 equals 0. It is in that standard form ax squared plus bx plus c. But we're going to plug in to find that discriminant. And again, we're only looking at the part of our formula, quadratic formula, under the radical sign. And to do that, we will get negative 32 squared minus 4 times 16 times 16. Okay, and I'm going to plug all of this into my calculator. And when I do so, I get 0. So I can say the discriminant for this problem is 0. Okay, well, what does that mean? If it's equal to 0, that means I have one solution. It would be a repeated real solution. So I could just put, I can expect to have one solution here. So fight that urge to want to write that number twice. Like you might plug into a quadratic formula and get -6 and -6. We would only write that one time, meaning that it swoops down and it's only going to touch the x-axis at -6. So it'd be -6, 0 would be our x-intercept. Remember, all of this quadratic formula is for us to find the solutions where our parabola is going to touch the x-axis. So we're looking for those x-intercepts. There's usually 2. In this case, there would only be 1. So let me grab my calculator and we'll graph it, and you can see. Or sometimes it doesn't touch the x-axis at all, so it does not have an x-intercept. So here I have plugged in our quadratic formula, our quadratic equation. I've asked it to graph it, and you'll notice it touches at, looks like 1 here, maybe pretty close to it. So it has 1 point that's on the x-axis, so there's our one solution.